In this video, I'll be talking about liquid chromatography, tandem mass spectroscopy calibration. This video focuses on the principle and fundamental of liquid chromatography mass spectroscopy and why it is necessary to perform calibration of this instrument and what uh, parts of the instruments need to be calibrated so we get accurate results. Now, what is liquid chromatography? Liquid chromatography is nothing but there's a sample that is dissolved in liquid and it is passed through a column, and the stationary phase is solid phase that is embedded with silica, and the sample is separated on the basis of its polarity and solubility to the column. So this is nothing but liquid chromatography, and mass spectroscopy is the detector wherein the sample that is separated, when it reaches the detector it gets ionized, and there's mass analyzer where the required masses are allowed to pass through quadrupole 1. Then there's a collision cell wherein a high voltage is applied and daughter ions are produced, and in mass analyzer 2 the daughter analytes are analyzed. So this is nothing but liquid chromatography mass spectroscopy. So as I mentioned that when the sample is separated in the stationary phase, it reaches the mass spectroscopy. So before entering this mass spectroscopy, the sample needs to be ionized, and majorly used ionization techniques are electrospray ionization technique and atmospheric pressure chemical ionization technique. So what happens in this detector, that is mass spectrometer, is that the masses are analyzed, and this is analyzed on the basis of their mass to charge ratio. And the first quadrupole, it selects specific masses, while the second quadrupole, that is also called as collision cell, what happens there is the parent ion that has been analyzed in mass analyzer 1, that is quadrupole 1, it gets fragmented and daughter ions are produced. And in quadrupole 2, that is mass analyzer 2, these specific daughter ions are allowed to pass. Now, why is it necessary to calibrate the instrument? Uh, like there are various parts in the instrument, so there is a need that these parts are calibrated time to time, and the reason is so that whatever result we get from the instrument is accurate and it is precise, and there is reliability in the result, like the second time we analyze we get the same result, so it should be consistent as well. Therefore calibration of the instrument is very important, so to get accurate result. Now the main types of calibration of LCMS is nothing but there should be mass calibration, the retention time calibration, and the calibration curve, that is the correlation coefficient. Now to simplify the calibration of liquid chromatography mass spectroscopy, it can be divided into two. You need to calibrate the HPLC and the detector, that is mass spectroscopy. It can be divided into these two parts. So when you come to HPLC, the first part that's need to be calibrated is nothing but your pump. Now what does the pump does? It will pump the liquid from the mobile phase bottle to the instrument throughout your analysis. Now suppose you have given the command to the instrument that the liquid should run in the instrument in 1 ml per minute. So that should be consistent throughout your analysis, or the result that you will obtain cannot be relied on. So the flow rates that needs to be calibrated is 0.51, 1.5 and 2 ml per minute. And there are 4 ports in HPLC, that is port A, C, D. So all these ports need to be calibrated. So and you're going to need a volumetric flask, 5 ml or 10 ml volumetric flask and a stopwatch. And whatever time is taken when you start the flow of the instrument, and you are collecting the liquid in the volumetric flask, you need to start the stopwatch. And whatever time is taken till the uh, liquid is filled in the volumetric flask up to the mark has to be recorded. So what is given here? The set flow rate is given, like it is 0.5 ml per minute. And the volume collected, it could be 5 ml or it could be 10 ml. And the time taken you have recorded in your stopwatch. So the measured flow rate is going to be the volume collected divided by the time taken to fill. So that will be your measured flow rate. And you need to calculate the accuracy of this flow rate. So that is going to be flow rate into 100 divided by measured flow rate. So that is going to give you the percentage. Now the acceptance criteria for this is 95 to 105% of the set flow rate. Now the second part that needs to be calibrated in HPLC is your column oven temperature, because in HPLC analysis this also plays a crucial part in separation of the analytes. So the set temperature could be 10 degrees Celsius, 35 degrees Celsius, 60 degrees Celsius, and you need to take 2 readings. And the acceptance criteria for this is plus minus 2 degrees Celsius of the set temperature. Now the third part that needs to be calibrated in HPLC is your auto injector. Okay. So how are you going to do this? You're going to fill the vials with 1 ml of your liquid, that is water, and you're going to note down the initial weight, and you're going to inject 50 ml from that vial, and then you're going to take the final weight. So W1 minus W2 is going to give the weight of injected volume. So the volume injected is going to be the weight of injected volume divided by the density of the water into 1000. So it should give you 15 ml. And this is done in, you need to take 5 readings of this. And the RSD of this is calculated. It should be less than or equal to 2%. And acceptance criteria is plus minus 3 ml of the set volume. Now the fourth part that needs to be calibrated in HPLC is your auto injector linearity and vial position. So what you're seeing here is that when you change the injector capacity that needs to be injected, that is, first it was 2 ml, then it was 5 ml, then it was 10 ml. So you're checking that this whatever injection volume you have given, it is accurate. When you're giving the command that 5 ml of the sample needs to be injected, the system is taking that 5 ml. So how you're going to calibrate it? You're going to see the linearity of the injection volume. So you're going to set it to 5, then 10, then 20. So it should be, you should get a linear graph when you're doing this. And you also need to check the vial position. So you're going to keep vials at different position, and you're going to check that whatever command you're giving to the instrument, it's injecting that particular sample. So the acceptance criteria for this is the correlation coefficient should not be less than 0.99. Now when you come to MS, that is your detector, the part that needs to be calibrated is your quadrupole. So what you're going to be calibrating here is your peak width and the mass axis difference. And you're also going to check the intensity of the masses. So the acceptance criteria for this is the mass axis difference should be in the range of plus minus 0.13 AMU, and the peak width should be in the range of 0.6 to 0.8 Dalton. Now to summarize this calibration, the parts that are calibrated in HPLC is your solvent delivery system, oven, injector. And when you come to the detector, your quadrupole is calibrated, and there is system performance check as well. Now this system performance check is done by doing a linearity test on the detector and the precision test. Now this linearity is going to be by how you're going to do this is you're going to prepare concentration like 2 ppb, 5 ppb, 10 ppb, 20 ppb, and when you're injecting this concentration, it should give you a linear response. So the acceptance criteria of this is more than or equal to 0.99. And system precision, you're going to inject same concentration of solution 5 times, and whatever area or response it is giving, it should be, the RSD should be less than or equal to 5%, and the RT, the RSD of the RT should be less than or equal to 1%. So this is how you're going to calibrate the system performance check. Now what should be the calibration frequency of the instrument? Normally, the calibration of mass should be performed daily or before a batch run, while the retention time can be calibrated weekly or as and when it is needed. And mostly in labs, there is an intermediate calibration and a full length calibration. The intermediate calibration is carried out every 3 months, where crucial parts is calibrated, that is your linearity is calibrated, system precision is calibrated, that is your RT, and the response is calibrated. And in full length calibration, all the parts of the instruments needs to be calibrated, that is in 6 months it could be performed. Calibration is necessary because whatever result you are giving, it should be accurate, and if you're performing that analysis later on, it should give you consistent result. So that is why there is a need that the instrument that you are using needs to be calibrated. It could be calibrated every 3 months, it could be calibrated every 6 months. So whatever result you're giving out, it should be accurate and consistent.